Hey math kids, today we're going to find the mean and standard deviation of a binomial distribution. And so, for given, maybe. Okay, so if we know that x is binomial, like that, then the mean, or mu, is equal to n times p. The variance, which is just the standard deviation squared, is given by this, which means the standard deviation is just given by the square root of all of that stuff. Okay, so basically we're just going to use this idea, knowing that we have a binomial distribution, to find that. So it says a fair die is rolled 12 times. And x is the number of sixes. That resulted. Find the mean, variance, and standard deviation of x. Okay, so essentially our n is 12 because that's the number of times we rolled the dice. Our probability of getting any one outcome is 1/6 because it's a standard six-sided dice. And so we would write our binomial distribution like this. Okay. Now, given that, if we're looking for the mean, it's right here, it's mu, and it's just n times p. So it's just 12 times 1/6, which gives us 12 over 6, which gives us 2. Okay? Now, if we find the variance, it's right here. So our n is 12, our p is 1/6, and then 1 minus 1/6. So when we do this, we've already figured this out. We know that's a 2. When we do this, we're going to think of it as 6 over 6. So 6 minus 1 is 5/6. And so that gives us 10/6, or if we reduce that, 5/3. So sigma squared is 5/3. And so if we find the standard deviation, we're just going to square root both sides. And so it's the square root of 5/3. Okay, so what does all this mean? Basically, we're going to expect a 6 to be rolled 2 times out of 12 trials. So that's what the 2 tells us. With a variance of 5/3 and a standard deviation of the square root of 5/3, which is 1.291 approximately, or 1.30 if we go 3 significant figures. And that's everything. If you need additional help, please come to Math Lab. Until then, calculator.